Okay, we're going to do just a quick lesson, 1 or 2 days on conic sections. So we're just going to hit the high points. And what are they? I'll show you in class a nice demonstration. Hopefully you saw it in the movie that we watched of Agora. But a line is sometimes considered to be a conic section. And you can recognize it if it can be written in the form mx plus b. There's a line. The next one we would talk about would be a parabola. And you could recognize that because it could always be written as ax squared plus bx plus c, or any quadratic. Okay, we're going to first talking about midpoints of lines. And of course, if you have 2 points that are on the same line, let's say I have 1, 3, and over here I've got 5, 9, or something like that. How would you find the midpoint there? So of course midpoint is nothing more than a middle. So somewhere around here is going to be the middle between those 2 points. And it's going to be the average x value and the average y value. So all you have to do, it's halfway between 1 and 5. So it's like an average. So I'm going to take 5 plus 1, divide by 2. That's my x value. And I'm going to take my y value, halfway between 3 and 9. 3 plus 9 and divide by 2. So I'm getting 3, I'm getting 12 to 6, right? So this point would be 3 and 6 for my x and my y. So just to quantify that in a nice formula for you, x1 plus x2 over 2, comma, y1 plus y2 over 2. Now I know you've seen this before. That would be a midpoint, we'll call it M. Think of it as averages. I am going to be there, I'll just be a little late.
International kids in my room, I can't change.
Ah, right. Okay, sorry. So midpoint, I know you've seen it before. Just apply the formula. Everybody should be able to find midpoints. Awesome. Let's go talk about distances, though. Distance between 2 points can be represented as a line. So if I have a point here that's -4, -3, and I have another point over here, I keep drawing the same orientation, 5, 6 is my second point. I want to know what is the distance between those. Well, to find that distance, it would be the length of that segment, right? And the nice way to find the length of that segment would be to draw a horizontal and a vertical, okay, such that this is a 90-degree angle, and now all of a sudden I'm looking at a squared plus b squared is c squared, right? So a squared plus b squared is c squared, refers to any right triangle, that's my Pythagorean. But how do you find the length a and the length b? Well, that's pretty easy actually. If I think about this point right here, has an x value of 5, because it's like that one, and it has a y value like this one, -3. Okay? Now, to go from x's, from -4 to 5, how far is that? If you remember, distance in general, before we went in one dimension, distance is equal to the absolute value b minus a. So you just have to subtract the numbers and make sure you have a positive answer to be a distance. So I'm going to take 5 minus a -4 and get 9. So this distance here is 9. To go from a -4 to a 5 would take 9 units, 9 steps. All right, now let's talk about the y values. To go from the y's, I'm going from -3 to 6, so 6 minus a -3. Oh, wow, it's also equal to 9. That was sort of unfortunate. But let's roll with it. So this one is also 9. So my picture is obviously point distance. Okay, we want to talk again about parabolas. We've done this before. We're going to do it again. This is just a quick reminder. If we want to write this in a standard form, it's going to be good practice for how we do circles next. So let's practice parabolas. The standard form, if you remember, was y is equal to a x minus h, quantity squared, plus k, where h comma k is our vertex of the parabola, x equal h is our axis of symmetry, and plus or minus a, right, that can be plus or minus, gives direction of opening. The A simply tells us if it's opens up tight, tall and skinny, or short and fat, that horizontal stretch or shrink. But plus or minus tells direction of opening. All right, so how can we write this? Remember, we're going to complete the square. So we're going to do plus box, minus boxes. So in general, let's give ourselves an equation to work with. How about x squared minus 2x plus 4? All right, take the first two terms, anything with an x, and then add a box. So you can have the number you want right there. But then you have to subtract that box, and then plus 4. Because it was there to start with, it's got to stay there. All right, what would I put in the boxes? What's half of 2? 1. What's 1 squared? 1. I put a 1 there, I put a 1 there. I chose that 1 in that way so that I could write this as a perfect square. X minus 1 is squared. Foil that out, you see that I've done that correctly. And then I have plus 3. So there, voila, I have standard form. And I could go back and give a vertex. 1, 3, vertex, x equal 1, axis of symmetry, and this one would open up because there's not a negative sign. Alright, so reminding you how to complete the square, let me do a hard one now. Okay, I'm going to try and write this one in standard form. So I need to make sure I don't have this number negative 2. That messes everything up, so it comes factored out. Negative 2 comes outside. I have x squared minus 8x. Double check, does that make plus 16x when I multiply back in? Yes, so that looks good. And now at this point, I'm going to add plus box, okay, inside there, because I want to be able to factor that. But then I have really gotten, this is a minus 2 box, so I have to do a plus 2 box here to cancel out the minus 2 box I've already done. And then I'll still have my minus 5 on the end. Alright, so what happens is minus 2 stays out front. Factoring here, I get x minus 4 squared. So that meant 4 squared is 16, needs to go here and here in the boxes. So that gives me plus 32, that's 32, minus 5, so it's plus 27. Cool, so I have now completed the square. I know this guy is going to have a vertex at 4, negative 20, plus 27. Axis of symmetry, x equal 4, and it opens down. So that's all good practice, and I really think that's all we're going to make sure we're good on midpoint, distance, and completing the square. That'll be a good practice for today.